Okay, can I just ask Heinrich the same question then? Because obviously there's got to be best practices in dense phase. Do the same principles apply in dense phase? Heinrich?
I think, yeah, we on lean phase, it's always the first thing is how much length do we have before we hit our first obstacle? Where my question generally is, how close is the closest structure? I prefer to go up as soon as possible. I think in Carsten's instance, where he went down on that conveying system is done in the mine, that was maybe another question. But generally, we are not phased about any acceleration lengths. I'll say you can, or where it bends is an enemy of pneumatic conveying. So it's a big selling point. We definitely use it as an advantage of the systems where we can change direction multiple times. Good practice is also not to have 2 bends or 3 bends right after each other. You might put in bends or change direction actually to slow down the material velocity. That is one way of slowing it down. And the theory behind that is, obviously, I'll say there's no CFD modeling or anything like that at the moment that can actually accurately predict what the material does in a pipeline. So what we are doing is we are taking it that the material entering the bend comes to a standstill, and then obviously you take it out again with your momentum and all of those math equations. So you can use it to an advantage. Disadvantage is you're adding an equivalent length. So for every bend, you are roughly adding 3 meters of conveying length to your system. So we tend to prefer rather going into a straight line. It just makes the math so much easier. I see Steve dropped off. The wind might blow a bit hard over the Pacific. But yeah, to continue answering it, it's once you really start going into complex long systems, because your conveying pressure tends to go up quite a bit. And if you go, say, for 6 bar conveying pressure, over that distance, if you, as the pressure expands and your pressure in your line goes down, the same amount of volume expands, say, 6 times. So you're sitting with 6 times the velocity. So you need to try and get rid of, let's call it, that energy. And sometimes bends might be an advantage where you can actually shed off some of that energy. But also it's an enemy that you might not be able to get that material going again. So it is something you need to be cognizant of and just take note of it, that you can't just go and put bends in the system anywhere without doing some calculations.